Hello everyone, this is Dr. Lennon, and we're going to look at some examples from the section about applications to economics. So from the first video, you should remember that there's four primary formulas that we're using in this section. We looked at the motivation for them last time. So we have four formulas. So the first is the consumer surplus formula. So all of these are just given by typical integrals. So we have the integral from 0 to capital Q of the demand curve, d of Q, minus capital P, the price point that we're looking at, and lowercase q is our variable. And then we have the producer surplus, which is very similar, but we're looking at the supply curve now. So we're, again, integrating from 0 to Q. And because the supply curve is increasing, the price that we're looking at is on top now. So we're doing capital P minus S of Q dQ. And then we also have the notion of the total surplus, where we just look at the demand minus the supply. So this is the combination of the consumer and the producer surplus. So this is the integral from 0 to capital Q of d of Q, the demand minus S of Q, the supply, integrated with respect to Q. So those are the ones all involving the surpluses. And then we have the other one, the future value formula, that involves some income streams. So the future value here is going to be e to the lowercase r capital T. So capital T is a constant, so is lowercase r the rate that we're investing at. And we're integrating from 0 to t, our time frame. And this is with respect to our income stream, f of t times e to the negative r, and then lowercase t is our variable. So these are our four formulas. So let's go ahead and do some examples of each of them. So the first example we want to look at is going to be a consumer surplus. So let's say the demand function for a particular vacation package is capital D of Q is equal to 2,000 minus 46 times the square root of Q. And again, it's always one good thing to check if you think about the graph, is this going to be increasing or decreasing? And if you think about what the square root of Q looks like, it would be an increasing function, but the negative will make it a reflection. So this will be a decreasing function, which makes sense for a demand curve. So what we want to do is find the consumer surplus when the sales level is 800. So they're giving us capital Q there. Again, we're going to need capital P in order to set up our problem. So we need to know the equilibrium point, both the price and the quantity. So capital P, we just plug in that 800 into our demand curve, 2,000 minus 46 times the square root of 800. And this comes out to 698.92. So that's our equilibrium price. So to set up our consumer surplus, we just plug everything into the formula above and then compute the integral. So we're integrating from 0 to 800, 0 to capital Q, and we're going to do our demand curve, which is 2,000 minus 46 square root of Q minus the 698.92 dQ. And then that will simplify to the integral from 0 to 800. And then 2,000 minus the 698.92 is 1301.08 minus 46. And I'm going to rewrite the square root of Q as Q to the 1/2. Remember, that makes the integration easier because we'll add 1 to that power, so it'll become Q to the 3/2, and then multiply in front by 2/3. So this will become The number in front is just a constant, so we just add a q to that. And then 48 times 2/3 is going to be about 30.67. And this is going to be q to the 3/2 power. And we're plugging in 0 and 800. Again, both of these things are being multiplied by q to some power, so when you plug in that 0, everything's going to go away. So that's all we really need to do is plug in the 800, and that comes out to our answer, which is $346,881.12. So that would be the consumer surplus for this example. So let's continue on with a producer surplus example. So in this example, we'll have a supply curve, and we'll be using formula number 2 from above. So let's say if a supply curve is modeled by the formula S of Q equals 200 plus 0.2 q to the 3/2 power. We want to find the producer surplus. When the supply is $400. Okay, so we're given the price in this case, so we still need to know the quantity to figure out integrating. So typically in the previous ones, we've been given the quantity and found the price. In this one, it's a little bit reversed, but we still need to know all the same information. So let's note that. We also need to know the quantity. When P is equal to 400. So set S of Q to 400 and solve. And this will give us the value of capital Q in the formula. So let's go ahead and do that. We know 400 should be equal to 200 plus 0.2 q to the 3/2. So we subtract 200 from both sides, and we get 200 equals 0.2 q to the 3/2. Then we want to divide both sides by 0.2. So we end up with 1000 equals q to the 3/2. And then we want to raise both sides to the 2/3 power to eliminate the 3/2 power. And we end up with our answer of Q is equal to 100. Now that particular Q is our actual capital Q for this problem, because we're trying to find the producer surplus at the quantity that's giving that supply of $400. So now we have everything we need to set up the producer surplus. So the producer surplus should be the integral from 0 to 100, 400 minus the supply curve, which is 200, plus 0.2 q to the 3/2. So we will have to distribute that minus sign. So that will end up as 400 minus 200, which will come out to 200 minus the 0.2 q to the 3/2. So we're integrating from 0 to 100, and we have 200 minus 0.2 q to the 3/2 dq. And integrating that, we have 200q, and then again add 1 to the power, which is going to be 5/2, and we're going to multiply 0.2 by 2/5. So that's going to come out to 0.08 q to the 5/2. And again, that's from 0 to 100. Since both terms are being multiplied by a power of q, plugging a 0 in will vanish, so we really just need to plug in that 100, and we get our producer surplus of $12,000. So that's our answer for this example. So let's go ahead and continue. Let's go ahead and look at a total surplus problem. So example. So a camera company estimates that demand for a digital camera is given by the demand curve D of Q equals 312 times e to the negative 0.14 Q, and the supply curve S of Q equals 26 e to the 0.2 Q, where Q is in thousands. So what price for the camera maximizes the total surplus? So that's going to be the equilibrium price. And in fact, what is the total surplus? So that is our third formula that we wrote down at the very beginning. So the first task is to find the equilibrium point. So let's start by doing that. So we just set D of Q equal to S of Q and solve for Q. So this is capital Q, comma capital P. So we set D of Q equal to S of Q and solve. So we get 312 e to the negative 0.14 Q equals 26 e to the 0.2 Q. So basically what I want to do is I want to put regular numbers on one side and the exponential terms on the other side. And it can only be accomplished with division or multiplication. So I'm actually going to divide both sides by 26 e to the negative 0.14 Q. So that will get rid of the 26 on the right-hand side, and it will get rid of the e to the negative 0.14 Q on the left-hand side. So in fact, that'll just leave me with 12 on the left, and on the right, remember, I would subtract exponents here, and 0.2 minus negative 0.14 is actually adding the exponent, so that's 0.34 Q. And then I can solve this by taking the log of both sides, so the natural log of 12 will just equal the exponent there, 0.34 Q. Remember, if you take the natural log of e to a power, you just get whatever's in the exponent. And then I divide by the 0.34 on both sides, and that will give me Q. So I get a value, if I plug that into my calculator, of about 7.31. Again, remember that's in thousands, so that's going to be thousands of cameras. And then to figure out capital P, I can plug that into either supply or demand, since those two curves are intersecting at that point, so it doesn't really matter which one I plug them into. So capital P is going to be approximately 26 e to the 0.2 times the 7.31. The only reason I'm using that squiggly equal sign is because I'm rounding, so these are approximate values. So our P value here comes out to about 112.18. So again, this is the price that maximizes the total surplus that they were asking for. And then what we want to do is we want to plug those resulting numbers into the total surplus formula. Again, the price isn't actually important when computing the total surplus. We really only need to know that quantity. So the total surplus here is given by the integral from 0 to 7.31. And then we take the demand curve and subtract the supply curve. So we get 312 times e to the negative 0.14 q minus 26 e to the 0.2 q dq. And then we integrate here. So again, the integration rule with the exponentials is just divide by that exponent. So 312 divided by negative 0.14 e to the negative 0.14 q. And then we have minus 26 over 0.2 times e to the 0.2 q. Nope, we integrated, so there's no more dq. We just need to plug in our limits. So this is going to be from 0 to 7.31. And if you plug in both numbers, you get negative 1361.78, and then minus a negative 2358.57. So this gives us our answer. Again, the so this comes out to $996.79. It said the quantity was in thousands, but in the example I didn't write down that the price was in thousands. If I'm mistaken and the price is in thousands, then this should be basically it would be 3 decimal points more, so it would be $996,790. So if the price was supposed to be in dollars, that would you would add 3 decimal places there. So I didn't write down that it was in thousands. I only wrote down that quantity was in thousands, but I don't have the book right in front of me to check right now. I'm just working off a set of my notes, so it's possible we're off by a factor of 1,000 there, but it would be clear if you were looking at a problem on WebAssign. Okay, so let's do a future value example and then call it a day. So in this example, let's see what's going on. So we have a retiree is paid $1,500 per month by an annuity. If income is invested at 5%, compounded continuously, what is the future value? After 10 years. Okay, so remember this future value formula. It's formula number 4 above, but I'll write it down again. We get FV is e to the RT integral from 0 to t f of t times e to the negative RT dt. So the things we have to figure out to apply this formula are capital T, lowercase r, and f of t. So lowercase r is straight away, that's the 5%, and this is as a decimal, so 0.05. Capital T is the 10 years we want to invest it, and then the income stream is the annual income stream. There's no typical increase to this that's planned in the problem other than after being invested, so it's that $1,500 per month. But this is an annual income stream, so we want to multiply that by 12. So this comes out to 18,000. So remember, f of t is annual income. So now we can set up our formula. So our future value here is the e to the 0.05 times 10. And we're integrating from 0 to 10 of 18,000 times e to the negative 0.05 t dt. And then these integrals are pretty easy to compute. So this just, the 18,000 is also a constant, so I'm going to pull that out front. So that's 18,000 times e to the 0.5. Integral from 0 to 10 of e to the negative 0.05 dt, t dt. And that is just going to be 18,000 e to the 0.5. And then do the antiderivative, which is this e to the negative 0.05 t. And then we just divide by that constant in the exponent, negative 0.05. And that is from 0 to 10. And that will come out to 18,000 e to the 0.5 times 7.8693. Okay, so this comes out to about $233,539.66. So that's it for the future value problem. So for most of these, it's really about setup. For producer and consumer surplus, you need to make sure you have capital P and capital Q. And for this future value, normally finding the income stream might have a trick, like in this example, we had to multiply by 12. But in general, the antiderivatives were all just basic rules that for these examples. I think in our text there aren't anything that's involving any real complicated tricks. Maybe you'll have a substitution here or there, but I don't think anything overly complicated. But anyway, so those are some more examples of applications to economics. This is Dr. Lennon signing off.